Hello, hi to everyone. Next, we are moving to the UNIT-2 CHAPTER-1 AC Fundamental Test Series. In this particular test series, from this chapter onwards, already mentioned in our app, expected questions plus previous year's questions. So together we form the test series. So in this particular test series, 20 questions are there. All 20 questions, most expected questions, and then here 2018 question paper, 2017 question paper, next 2016 question paper, 2016 question paper, 2014 question paper, 2014 question paper, and IES previous IES questions, as well as IES 2015 question paper. So some of the important questions related to that different examinations. So all of you clear about that? So you don't skip this video and then see this video. In your examination in this particular chapter we can expect two questions, at least one or two questions. Okay, let's start out the first question. AC current given I is equal to 14.414 sin omega t plus pi by 6 as RMS value dash amperes and phase of dash degrees. Okay, in this particular case I is equal to Im sin omega t plus theta. You know this relation. From that, what is the Im? Im is 14.14. Once you know the Im, IRMS, you know the formula from theory class. In our mobile app, we explain all theory classes related to that. Just go back to our app and then see all the videos. Then you will get this particular formulas, everything concept. IRMS is equal to Im by root 2. Okay. So what is the Im here? 14.14 divided by root 2. You will get 10 amperes. Okay, current is 10 amperes. Next, the phase angle dash degrees. So phase angle phi is equal to pi by 6. Pi by 6 is nothing but a pi is a 180 degrees by 6. That will be equivalent to 30 degrees. So option A is the correct option. Is it okay? Next, we are moving to the second question. The RMS value of sinusoidal AC current equal to the value of angle dash degrees. It is a 45 degrees. Okay, option B is the correct option. Okay, why it is exactly 45 degrees? We have a derivation in that. Just go back and then see. And then two sinusoidal AC currents are given by the equations. These are the two sinusoidal currents. The phase difference between these terms. Okay, so they're asking about the phase difference. So here it is a sine term. The first of all you can see this is a times sine term. Okay, no problem. So it is a 5 by 3, it is a 5 by 4. Phase difference, that will be theta is equal to pi by 3 minus, difference is minus. Here already minus is there, 5 by 4. That may be equivalent to 5 by 3 is nothing but a 60 minus pi by 4 is nothing but a 45 degrees. So that will be equivalent to 105 degrees. What is the phase angle now? 105 degrees. Okay. Next, question number 4. In the question number 4, AC current are given by I is equal to Im sin omega t, that is 100 sin omega t. Achieve the value of 50 amperes dash seconds. That means this particular waveform, how much time it will take 50 amperes. Okay, that is a question. So this type of numerical example already explained in the conventional problem part in our mobile app. Okay, we'll see now this particular solution. In this particular case, I is equal to 100 sin omega t, that is a sin phi t, right? What is I value? 50 is equal to 100 sin 100 pi t, right? So now this 100 in this particular left hand side, it will be 1 by 2, right? Next, sine 100 into pi is nothing but a 180 degrees, right? That will be 100 into 180, 1800 t. Here 100 is also there, 180. So 3 zeros. So 18,000 t. So from that sine opposite side, sine inverse. 1800 T 18,000 T is equal to sine inverse 1 by 2. What is the sine inverse 1 by 2? That is a 30 degrees, sine inverse 1 by 2. So from that, time T is equal to 30 by 18,000. That will be equivalent to 1 by 600 seconds. So what is the option? 1 by 600 seconds. Option is A. Okay. Next, the average value of AC current I is equal to, this is this particular current they are asking about the average value. You know, I gave the some derivations, average value, RMS value, form factor and peak factor in our theory class, right? So from that I know the formula for average value, I average is equal to average value formula 0.637 into IM. This is the formula for average value. So 0.637 into what is IM? This is IM, because you know I is equal to IM sin omega t. This is the IM. From that 63.7 amperes. What is the current now? 63.7 amperes. Option D is the correct option. Next, the RMS value of sine wave whose average value equivalent to. So they provided RMS value of sine wave whose average value equivalent to 7.644 average value. So you know form factor K is equal to RMS value divided by average value. You know form factor constant for sinusoidal. Every waveform have a separate form factor. So in case of sinusoidal waveform, you know from our theory class, it is a constant value 1.11. Okay, is equal to RMS value. You need to find out RMS value. You need to find out what is the average value is given 7.644. From that, RMS value of current is equal to 8. It is about voltages. RMS value of voltage is equal to 8 after multiplication 8.484 volt. So what is the answer? Option D is the correct option. This is the question from 2018 question paper. Next, 2017 question paper. If V is equal to Vm sin omega t is the voltage across the capacitor, then the current is. So you know the voltage across this capacitor is, this is a waveform. They are asking about the current. You know the angle between voltage, for example, you are taking the voltage as a reference, current is leading by 90 degrees. Okay, current is leading in case of capacitor. So leading is nothing but I is equal to Im sin omega, lead already mentioned, plus how many degrees? 90 degrees. That is a 5 by 2. That is 180 by 2, 90 degrees. So just verify the options. Option D, Im sin omega t plus 5 by 2. Okay, this is the option D is the correct option. Next we are moving to the question number 8, 2017 question paper. A current I is equal to 100 sin omega t minus 3 pi by 8. Okay, so now it is produced the voltage of 30 sin 300 t applied to a circuit. Okay, current and voltage. So the estimated value of impedance, they are asking about the impedance. Z is equal to, you know, Z is equal to V by I. V RMS divided by I RMS. You know what is the values of maximum value? This is the Im, this is the Vm, right? So impedance is equal to RMS value by RMS value of voltage by RMS value current, but you know maximum values. So maximum value and RMS value relation, RMS value is equal to maximum value divided by root 2. You know this formula. So from that 30 by root 2 by 10 by root 2. This root 2 get cancelled. You know 3 ohms is answer. What is the option? Option D is the correct option. Okay, next we are moving to the question number 9. This is a 2016 question paper. A sinusoidal AC has a frequency of 50 Hz and a peak value of 20 amperes starting from 0. Okay, that means we have a current value starting from 0. It is a 50 Hz is a frequency. The maximum value is a 20 amperes, right? how long time will it take to reach the 10 amperes. That means, for example, this is the 10 amperes, how much time it will take to reach that particular value they're asking. Okay, let us see. This particular it is a frequency, it is IM value. What is the IM value is given 20 amperes, and frequency is equal to 50 Hz is a frequency. So from that, I is equal to Im sin omega t. What is the I value they are mentioned? 20 amp, no sorry, I value is a 10 amperes because it reached to the 10 amperes instantaneous values is equal to, what is the peak value? 20 sin omega. Omega is equal to 2 pi f. It is a 2 pi f is a 50 Hz is a frequency. 10 by 2, so that is a 1 by 2 sine 2 pi. 2 pi is nothing but a 360 into 50. So finally omega t, right? Here t is there, t, here t. So you want time t. So therefore time t is equal to sine inverse 1 by 2 is equal to 30 degrees already 360 into 50. Okay, that will be equivalent to 1 by 600 seconds. What is the current now? 1 by 600 seconds. Option B is the correct option. Okay, so if while you are attending the exam, first of all, the complete basics, everything in the theory part, then you can attempt the test series, then you will get the confidence. So our app is providing the systematic way. Once you complete the chapter, we will take up the previous questions, expected questions, and then we will give the explanation and we will provide the test series. Okay, so still now we are completed the unit 1 completely, and unit 2 chapters, and unit 5 already started. The unit 5 chapter 5 completed, and chapter 4 I am going to upload it. So everything is systematic manner. Don't worry about the exam date. Now we are conducting there for KVS TGT 2023 for LDC, limited requirement examination. So our examination will be on mostly in March. So maybe your expected date. That's why you can go to our app, and then now this is the right time to start your preparation. Okay. Next, coming to the question number 10. And the question number 10, a sinusoidal voltage V of t is equal to 100 sin 1000 t applied pure capacitor. The power is given by. They are asking about the power. Okay. This is the V of t. This is the capacitor. So from that, capacitor's value is 100 microfarad. So Vm value is 100 volt, right? And omega, this is a omega. Omega is equal to 1000. From that, from our basics of pure capacitor from the theory class, Im is equal to Vm by Xc. Already gave. From that Xc, Xc is equal to 1 by 2 pi Fc or 1 by omega c. From that, Xc can replaced by omega c, right? So 1 by omega c is nothing but a Vm omega c. All of you got my point. So from that, Vm is 100, omega is equal to 1000, and capacitor is equal to 110 power minus 6. From that, I got the value of the maximum current is at 10 amperes. So my expected answer will be power, right? I got current. Next, once you got the current value, I is equal to Im sin omega t. It is a capacitor, right? Whenever it is a capacitor, leading power factor plus 5 by 2. Once maximum current 10, sin omega is 1000, right? T plus pi by 2, right? This is a current I got. This is a voltage, this is a current. They are asking about the power. So finally, I will do here. Finally, power P is equal to Vi. Okay, P is equal to Vi. What is the V? 100 sin 1000 t, and I is equal to 10, right? I is equal to 10. It is a sine theta plus pi by 2, that can be converted into cos theta. Okay, in the first quadrant. So cos 1000t. Okay, so from that, this is a sine term, this is a cosine term. So you know the formula for 2 sine theta cos theta is equal to sine 2 theta. You know this formula, right? From by using that formula, you know 1000 by 2 I am using here. So it is a 500 sine theta into cos theta, from that sine 2 theta. So sine 2 into theta is a 1000, right? Theta is a 1000 t. So finally it is a 500 2000 t. 500 2000 t is the answer. Option A is the correct option. So all of you clear about the solution for question number 10? You are using the trigonometry formula. Here 100 into 10,000, but 2 I want. That's why it is converted into 500 into 2. That 2 I am using this formula. Then there is no 2 here. So that is converted into here. Okay. Next, question number 11. In the question number 11, power dissipated in ideal resistor. Already explained to you. Ideal resistor power dissipated is equal to 0. There is no power dissipation in ideal resistor. Okay. Why it is 0? We are explaining in the theory class. I don't want to waste your time, because you are if you are my mobile app subscriber, already explained there. That's why you can go to there. Already we have completed the theory classes, right? So if you are not subscriber to my course, just go and search the mobile app. In our description it is available. Just attend the classes, then you will get the complete confidence about that. Next, question number 12. In the question number 12, what is the product of form factor and peak factor? You know, form factor and peak factor. Form factor formula, RMS value divided by average value. Peak factor, maximum value divided by RMS value. So from that, these two are get cancelled. The maximum value divided by average value. So what is the option? Maximum value divided by average value. Option B is the correct option. This is a 2014 question paper. Next, this is a question from IES 1992. They are asking about when quality factor of a circuit is high. When a quality factor circuit is high, so what is the effect? Maybe power factor in the circuit is high, impedance in the circuit is high, bandwidth is large, none of the above. So I will explain with the help of the some formula. You know, R is equal to Z is equal to R plus J omega L, right? So that will be equivalent to R is a common 1 by J omega L by R. From that, you know, this is the quality factor Q formula. You know, from the our derivation, quality factor is equal to omega L by R. So from that, you know, quality factor increases. What will happen? The impedance is increases. So quality factor increases, impedance is increases. Option B is the correct option. What if you got my point? Next. So question number 14. In the question number 14, a series circuit containing passive elements, that is a resistor, inductor and capacitor. The following current applied, voltage and current, these are going to be applied. From that, you know, this is a sine waveform, this is a cos. I need to convert this cos into sine theta plus pi by 2. So then it is converted into cos. So that's why V is equal to 200 sine 2000 t plus 50, and I is equal to 4. Cos is converted into sine, then only can analysis is easy. 2000 t plus already 13.2 plus pi by 2, that is a 90. Then it is converted into sine. Both are sine, you can compare the phase angles. So this phase angle difference theta is equal to, this is a 103.2 minus 50. The phase difference, both are plus, right? So that will be equivalent to 53.2 degrees. Now my question here, how to analyze that particular components are resistor, capacitor and inductor You know, theta value, for example, you got 90 degrees, for example. What about the power factor? Cos phi is equal to 1. Whenever cos phi is equal to 1, that is a resonance condition. Only resistive load is present. Only resistive load is present. Now my question here, it is not a 90, it is not exactly 90 degrees. It is a 53.2 degrees. That means that the frequency levels of 1 by omega c less than omega L, okay, as well as omega is less than the resonance frequency, both the conditions are satisfied, then these conditions less than the 53.2 degrees, those circuit is a resistor, inductor and capacitor. It could be either resistor, maybe capacitor, or resistor, inductor and capacitor. This particular option, it could be either resistor or capacitor, but we can't decide it that, okay, or resistance, inductance, capacitance, RLC. So option D is the correct option. Okay. Next, question number 15. In the question number 15, this is a question from IAS 2010 question paper. For AC circuit, V of t is equal to 160 sin omega t plus 10. I of t is equal to 5 sin omega t minus 20. Then reactive power absorbed by the circuit. So already explained for you active and reactive power formulas. What is the formula for reactive power? Q is equal to VI sin theta. That is a reactive power formula, you know. Units are VAR. Now here see, what is a V maximum value? 160. So Vm is equal to 160. From that, Vrms, all are RMS values only. Okay, Vrms is equal to 160 by 2, root 2. Next, current I is equal to, Im is equal to 5. From that, Irms is equal to 5 by root 2. Got my point? Next, what is the phase angle? Theta. Right. Theta 10 minus 20. That means theta is equal to 10 of minus 20. Phase difference. That is 30 degrees. Then you can apply here 160 into 5 root 2 into root 2. Okay, sine 30. You know, sine 30 1 by 2. Here root 2 into root 2 is 2. That will be equivalent to 160 into 5 by 4. It is a 200. It is a 1 time, it is a 4 times 200. VAR is a units. So what is option? Option B is the correct option. Okay. Next, question number 16. In the question number 16, which of the following can produces the maximum induced voltage? This is a question from 2015 IEX exam question paper. You know, formula induced EMF is equal to E is equal to minus L into di by dt, for example. So from that, you know, 1 by t, it is nothing but a frequency, right? So minus L, for example, delta, change in current into change in frequency, because 1 by t is equal to F, change in frequency. Now my question here, if you induce the maximum voltage, the current will be maximum as well as frequency is a maximum. Then only induced EMF is maximum. Just verify the options. It is a DC, there is no question about the frequency. You can neglect it. This is a DC, the frequency will be 0. Coming to here, which frequency is high? This is the frequency is high. Current is same, okay, there is no problem. Whenever current is more, the induced EMF is more. Both the options current is same, but frequency here high. That's why option D is the correct option. Okay. Next, question number 17. A current is said to be alternating when it changes in, so both magnitude as well as direction, right? Next, question number 18. The period of alternating quantity, time taken to complete 1 second in second, is a cycle. Okay. And then question number 19. Okay, the power factor of AC circuit is equal to, this is the AC circuit. You know, the power factor is nothing but according to the definition, it is an angle between voltage and current. So it is a cosine of an angle between voltage and current. From the definition, option A is the correct option. And then last question, the value of peak factor for sine wave is, the value of peak factor for sine wave, it is a constant value 1.414. You know, maximum value divided by peak factor. maximum value divided by RMS value. Okay, you know maximum value, for example, it is a current IM, that is a peak value. RMS value is equal to IM by root 2, that will be 1.414. Okay, option B is A is a correct option. So this is about the explanation about AC fundamentals. If you are enjoying the class, just go to the description. So our mobile app is available. Still you have interested towards our classes, you can download our app and then attend the theory classes. Thank you.